Hey class, how you doing? Oh my goodness, here we are, another quarantine virtual week, and yet we still have to get a lot of work done. Know that I'm going to miss you a lot this week, and certainly look forward to seeing you guys next week, but we've got to buckle down and knock out what we were going to do. If you remember in class, we talked about completing 2 tests this week and 1 learned lesson. And so we still have to keep that schedule, and I trust that you'll be able to do that. My intent is that we're going to be able to do it through these videos. We're going to be doing some YouTube videos. Those of you that were in my class last year when COVID first hit, you'll recall going to these YouTube links. I think this will work pretty well. You'll note that in the message I sent to you in Google Classroom, I've attached both a copy of this test prep, and you'll also note a link to this video. And so if you clicked on that link, you obviously are now watching my video with me, but this video is actually pertaining to the test practice, the test prep for you to be ready. I will release a different test tomorrow, Tuesday, and this is an open book, call your friend, call Captain Melton test. Do you hear me say that? It is an open book, call your classmate, call Captain Melton test. I recommend you go through your book first, then your classmates, and if you still struggle with that information, then call me, and I'll make sure to include my phone number in that release, and I can help you through that. When I release the test tomorrow morning, and it'll be first thing in the morning, I'll release it on Tuesday, you need to know that you have from Tuesday morning all the way to 9 o'clock Tuesday evening to complete that test. Any test received after 9 o'clock will start receiving points off for every hour past 9 o'clock. You don't want to do that. You have a whole day to take this test. You can knock it out, all right? But this video is going to pertain to the lessons. Listen, I'm not going to go through every one of these lessons. I put this on there so that you can personally go and review this. I'm going to tell you which lesson the questions will be able to answer for you so that you can go back in your book to that lesson to help. But there are a couple questions I want to be able to answer for you. Let's start with one of them. You'll notice that on my board behind me, I've got questions numbered. And after I erase these, I'll do a few more after that. But these are the questions I remember we had struggled in the class a little bit. And so I want to cover those again in my video. Let me find my purple marker. You'll notice question number 1 from our review, and you'll go back and find that in your attachment. It's a ratio question. The question says the ratio of good guys to bad guys was 12 to 5. So I'm going to automatically write down in my notes, good guys to bad guys is 12 to 5. I just automatically write that down in my notes. If there were 72 good guys, how many bad guys were there? That's how you answer the question. And so I'm going to write down 72 up top because good guys is on the top line. 72 should be on the top line. And your question is what bad guys are there total? And now you're setting up your question here. 12/5 ratio equals 72 over what bad guys we're trying to find out. Now, ultimately, you end up doing cross multiplication. You'll remember this. And that helps you set up your algebraic expression. All right? So now I'm going to write 12BG equals 5 times 72. At this point, you should be able to solve this. You'll know how to do this. You'll end up having 5 times 72, whatever number that is, and you end up with 12 times bad guys. Okay? Remember, the name of the game is to get BG by itself. Divide it by 12. Divide this side by 12, and whatever answer you end up with, that'll tell you bad guys equals. All right, so that's number 1. That's one ratio version. Let's go to question number 2 on your study guide. Question number 2 is similar to the ratio problems. Now, number 2 reads, get close enough for me, Carly, so I know they can hear me.
Okay.
The ratio of yellow marbles to purple marbles was 13 to 4. So I go ahead and write that down in my notes. Yellow marbles to purple marbles is 13 to 4. It gave me that ratio, okay? If there were 102 total marbles in the bag, How many were yellow marbles? Well, this is a different ratio question than the first one. It's a little different. This one tells you the total marbles in the bag, and you have to figure out how many are yellow. So you set it up just a little bit differently. You go back to the ratio and realize that 13 yellow marbles plus 4 purple marbles is 13 plus 4. That gives you 17 total ratio, right? And then you got to come back in and set up your problem here. The question, since it's asking for yellow marbles, you will use the number of ratio from yellow marbles. So I'm going to write 13.
Hello.
And I'm going to put that over 17. Okay? And then the question, of course, is how many yellow marbles? Since yellow is on top on this side, yellow is going to be on top on this side. Since total ratio is on the bottom on this side, total marbles is on the bottom on this side. And again, I'm setting up my algebraic expression. And I'm going to cross multiply. 17y equals 13 times 102. Again, you solve this. The name of the game is to get it to say y equals, right? So let's do 13 times 102. Whatever number you get will end up being 17y equals that number. Remember, get that y by itself. Divide by 17 on this side, divide by 17 on this side, and whatever this number divided by 17 will be your answer. And that'll tell you what y equals. Remember, you always do y equals whatever number you end up with. So that's an example of ratios from question number 1 and number 2. If you have a question about those, you can always go back to lesson 38 specifically. Go back to lesson 38, try to work it out yourself and see what you can do. You will see an example of these kinds of problems on the actual test giving out on Tuesday. All right? Number 3. No, I'm not going to do number 3. I'm going to do number 5. It says to use 4 unit multipliers to convert 50 square meters to square inches. I know we don't like doing these, but we still have to think these through. Remember, you want to go from 50 meters squared to inches squared. That is your goal. This is where you want to head to. All right? So let's take the unit multipliers that we know. We know that 100 centimeters equals 1 meter. Since we're working with meters, it's important to know how we're going to go from meters to inches. So I'm going to pick meters and centimeters. I also know that 2.54 centimeters equals 1 inch. Now I'm able to go from meters to inches using these 2 unit multipliers. Now, if you remember, both of these can be used in multiple ways. You can either set up a ratio of 100 centimeters over 1 meter, or you can use 1 meter over 100 centimeters, depending on which one you need to use. I think you'll remember that in class. Same thing with 2.54 centimeters over 1 inch, or 1 over 2.54 centimeters. So let's actually, all I've done here is set up my notes. These are my side notes so that I can actually set up the problem. Okay? That's a lot of work on the side that you've done that'll help you actually solve the problem. Now we're going to set up the problem. I'm going to set up 50 meters times meters. Okay? And you've got to remember that this technically means over 1. And now I'm going to multiply it times some unit multipliers. Let me erase this so I can actually have some room to work with. Okay, so I've got 50 meters times meters because it's a meter squared. I'm making that point here. Okay, I've got to go from meters to centimeters. So I've got to use this unit multiplier. How do I choose whether I do 100 centimeters over 1 meter or 1 meter over 100 centimeters? If you'll recall, the reason you choose this is because meters up here will now be eliminated. So this meter down here will eliminate this one, and this one will eliminate this one. That was very important. Now I got to go from centimeters to inches. Which unit multiplier do I choose? Well, I think I'm going to choose the 1 inch times 1 inch over 2.54 centimeters, okay, times 1 inch over 2.54 centimeters. The reason I'm using 2 of these at a time, again, I'm reminding everybody that the original problem started with meters squared. You've got to get to inches squared. So what we've just done here is we've eliminated this centimeters and this centimeters, this centimeters and this centimeters. What is left? You're left with 1 inch, 2 inch. Does that sound familiar to you? That is now inches squared. And then you solve the problem. You've got 50 times 100 times 100 times 1 times 1. And I'm going to let you guys do that math. And then you have 1 times 1 times 1 times 2.54 times 2.54. And you divide that, or you use that number to divide the original. So you end up having with a number on top and then a number on the bottom. And that will give you your answer. And always remember, the answer is some number inches squared. Don't forget to circle it for me, okay? So that's an example of question number 5. Okay, take a look at question number 11. I'm going to drop your attention to that. It tells you to simplify factor if necessary. You'll recall we did one of these in class. This is an example of the ones that I told you use your distributive property backwards. So I want you to be able to take that top line, work a distributive property backwards, and then you're going to be able to simplify. Let me give you an example. This top line, 6xy plus 36x squared y, worked backwards, will be 6xy times 1 plus 6x. And then the bottom number just comes over, 6xy. Remember, you would have gotten something like this top line, and you would have been told use the distributive property. So you'd have taken this and multiplied it times that and multiplied it times that, and you would have ended up with this number. You see how it works backwards from the distributive property? All right, but you went from this number, this example, to now here you have factored it out. From this point, you can actually eliminate. 6xy eliminates the top 6xy, and you are left with 1 plus 6x. And there's your answer. 6x. 1 plus 6x. Number 11. Okay? That information, if you need to go back and look at how to do an example of questions 11 and 12, you can go back specifically to lesson 35. That'll help you out with that. All right? I do want to give you an example of lesson 13, or number 13, sorry. Let me write this out. X squared, y to the negative 3, z to the negative 1, over z to the negative 3, y, x to the negative 3. Okay? If you look at number 13, Curly, can they see me from there? Okay, quit being creative because I'm not sure they could hear me the further you get, okay?
Okay.
Number 13, it says write the answer with variables on the numerator. Don't forget, top line is the numerator, bottom line is the denominator. That's how I remember the heavier numbers on the bottom. And so somehow you want to get this bottom line to the top. Well, how do I do that? Remember that you can change your bottom numbers to flip them back up to the top. So let's write this a little bit differently. We'll have I'm going to do it under here so you can see it. Let's do a z to a positive 3, a y to negative 1, an x to a positive 3, and I have just moved these to the top line, and I'm going to put an x squared, y to the negative 3, z to a negative 1. Now, am I done here? I know I've put them all in the numerator. That's kind of like saying over 1, right? It's in the top line. But now I have to combine them. I've got to find the like terms, okay? z to the third, and a z to the negative 1. So I've got a 3 minus 1. That gives us a z squared, a y minus 1, and a y to the negative third. That gives me a y to a negative fourth. An x third, x squared, gives me an x to the fifth. And I believe that's my answer. And I put those all in the numerator. That's just an example of that. I covered that because we covered it earlier this week in the lesson. Let me see if I can use another one. I'm going to give you an example of number 14. Here we have sorry, let me erase that.
Where are you? Okay.
A negative squared over b squared. Can they actually see it clearly?
I don't know. I'm trying to move it so they can see it from your, like, away from your hand.
5ma squared.
Here we go.
Over b to the negative squared. All right. At this point, you start with this problem. This is number 14 in your study guide. And the question says to use the distributive property. Okay. Remember, in the distributive property, you have to take everything on the outside and multiply it times this one on the inside and this one on the inside. So let's figure that out. All right. What is a to the negative squared times b squared? You end up having a to the negative squared, b squared, over b times a to the third. And then, of course, you bring down your minus sign. And then again, you do this times everything over here. So I have a to the negative squared. We'll combine it with that. So you end up having a 5m a to the 0 over b times b. So you end up having a 1 minus 2. So you end up having a negative 1. So a b to the negative 1. Now, I'm not done here. You still have to see more work in here as you're going. So let's see if we can combine some things to make this a little easier. First of all, that a to the 0, we know that that's going to mean 1. Okay? We also have a minus over here. So we can actually bring that minus up to the top. So here we have a, also we have that minus over here. We can bring that minus down. So let's start with that one actually. Okay, so you have an a to the negative 2. Let's bring that down. So you have a b, a squared, a to the third, and you still have b squared up top. Okay, then you have a 5m. We're going to bring that b up to the top. Okay, so now it's kind of like a b over 1. I know I'm making this kind of messy, but let me rewrite it a little bit. So I'm going b squared over, and I'm going to combine the b, which is already there, and an a squared and a to the third. Makes it an a to the fifth minus 5mb. That is your final answer on number 14. Okay? At this point, I want to go through each number and tell you which lesson will help you with it. And just make a note of that. If you get stuck on that, go back to that lesson and look it up, okay? Question number 1 and 2, you can go back to lesson 38. Question number 3, you can go to lesson 32. Question number 4, you can go to lesson 33.
433.
Question number 5, you can go back to a lesson 10. That's about the beginning of the year.
10.
Question number 6, you can go back to lesson 37. Question number 7, you can go back to lesson 30. Question number 8, go back and review lesson 39. Question number 9, go back and review lesson 28. Question number 10, A and B, go back to lesson 36. Question number 11, go back to lesson 35. Same thing for number 12, go back to lesson 35. Question number 13 and 14, check out lesson 40. Question number 15, go back to lesson 21. Questions number 16 and 17, go to lesson 31. Question number 18, go to lesson 19. Question 18, go to lesson 19. Question number 19, go back to lesson 3. That's back at the beginning of the year. You may not have a memory of that. Question number 20, go back to lesson 20. Now, what I recommend you do is work through these questions. If you work through these questions today, your take-home test tomorrow will be a little bit easier for you to work through. Don't do this lightly. A take-home open book, call your friend, call the captain, is not that easy of a test. Remember, because it is open book and it is call your friend and call your captain, I am grading this a little bit more stringently. I expect excellence on this test. Check out my number, call my phone, text me if you need more questions. Know you're loved, know you're prayed for. Bye.